All right, so one extension to solving a system of two equations and two variables is throwing in a third variable. So this video is going to look at that, how we can extend the ideas to be able to solve a system that's three equations with three unknowns. All right, and you really kind of have to get the general concept and then just be super careful about positives and negatives. All right, what you'll want to do first, I'm going to be referring to these equations, is I want you to think about those first three equations. I'm going to call them equation 1, 2, and 3. Okay, and here's going to be our overall plan. We're going to look at the original system and decide on a variable that we want to cancel out, want to try to eliminate. And then what we're going to do is take two of the equations and work to eliminate that variable. And then we're going to take a different two equations and eliminate the same variable. Okay.
Here's your first time.
So what I'm going to do on this one is I'm going to look at it and I notice that really I could eliminate X, Y, or Z pretty easily. Okay. So I might make the decision, let's just go ahead and work on eliminating X. And see how this X is just a 1X, and then the Y in the third equation is just a 1Y, and the Z in the second one is just a negative 1Z. Any one of those three could have been used kind of as the basis for trying to eliminate X or eliminating the variable in the other equation. So I decided I was going to eliminate X. So here's what I'm going to do. I'm going to take the first equation and the second equation. And I see on the second one a 2 in front of the X. So I'm going to take the first equation and multiply by negative 2. All right, so my new first equation becomes negative 2X, positive 4Y, negative 6Z equals negative 44. And your signs, you just need to write it and then double check it before you move on. Make sure you have the signs correct. Okay. And then that new equation is exactly the same as the old one. It just has a different name, but it's the same set of points. All right, now the second equation, I'm not doing anything to, just writing it so it's lined up with the other one. Then I'm going to add those two equations together. I've got it set up where the X's are going to cancel, and I get Y minus 7Z equals a negative 39. Okay. Now label that equation. In fact, I wish I had written that. I'm going to write that in a different color because that's a really important equation. So let me kind of emphasize that. So that's Y minus 7Z equals negative 39. Call that your equation 4. Okay. Here is the whole key to the idea. I need to now work to create an equation 5 that I'm going to pair up with equation 4. So it has to also have a Y and a Z in it. Must have the same two variables. So once I've decided to eliminate the X right here, when I go back to my original equations, I need to eliminate the X again. Okay. So let me change to blue. What I'm going to do, I think I'll still use the first equation, but I'm going to put it together with the third equation. So instead of multiplying by negative 2, I'm going to be multiplying by negative 3. Okay. So that's going to give me a new first equation. Let me do it in blue. Okay, so now I'm working on the next pair. My new first equation becomes negative 3X, positive 6Y, negative 9Z equals a negative 66. Then I'm going to bring the third equation and line it up right underneath that. And then I'm going to combine those, and that's going to give me my equation 5. And see how I made the X go away again? That's really important. That'd be the big note to make. You must eliminate the same variable both times. Okay. So you need your equation 4 and 5 to both have the same two variables in them. So now when I combine these, I get a 7y minus 14z equals negative 98. Okay, so here's what we're going to do. We're going to pull equation 4 and equation 5 together. So we have a system of equations now, and we're back to what we did way in the beginning when we were solving two equations with two unknowns. So now I'm ready to look at it. I think what I'll do is come in here and multiply by a negative 7. And then I'll pair that up with a positive 7y, and that'll cancel out. So I have negative 7y plus 49z equals positive, because a negative times a negative would be positive 273, positive 273 right there. Now equation 5, I'm not really changing. So I'm just going to bring that along, get it all lined up. So these were my two equations. And I got it ready to eliminate, and I chose to eliminate my y's. That adds up to be 0. And I have 35z equaling a 175. And then I'm going to divide by the 35. And I get a z equals 5. Okay. All right. Now, if you've gotten to there, you're really basically home free. What you're going to do now is you're going to take the z equaling 5 and you're going to plug it in to find one of the variables you don't know. Just don't go back to equations 1, 2, or 3. Go back to 4 or 5. Okay. So I'm going to go back up to maybe equation 4 where I had this. Okay. Y minus 7z equals negative 39. Okay. Then I'm going to take the 5. It's z, so right there where z is, I'm going to put 5 in there. Okay, and so I wind up with y minus 35 equaling negative 39. And when you add 35 to both sides, you get that y equals negative 4. Okay. All right, and so we need x. And when you look, you don't have any x's anywhere except for in the very, very beginning. So what you want to do at this point is pick equation 1, 2, or 3. Now, sometimes there's a real advantage to picking one over the other. But on this one, they all have negatives in them, so I'm not sure it really matters. I'm just going to use the first one. So the first one is x minus 2y plus 3z equals 22. But I needed to go to an equation that had the x in it. So I just picked equation 1. Then what I'm going to do is right here where z is, I'm going to put a 5. Right here where y is, I'm going to put a negative 4. So I'll have x minus 2 times negative 4 plus 3 times 5 has to be 22. Watch your positives and negatives. That'd be plus 8 plus 15. These are on the same side, so that'd be x plus 23 equals 22. Then I'm going to take away 23 from both sides. And I'm going to get x equals negative 1. Right? And then just like on the other ones, you write it, only instead of an ordered pair, you have an ordered triple, and it should be in alphabetical order, x, y, and z. So negative 1, negative 4, positive 5. Okay. Now, something I didn't share during the face-to-face or the virtual session was back up here. What I normally do is I take the negative 1, the negative 4, and the 5, and I imagine them going in place of the x, y, and z on each equation. Only I use the top one to find x, so I'm just going to check on the second one. So see how 2 times negative 1 would be negative 2 plus positive 12. That would be 10. 10 minus 5, that would equal 5. And then I do the same thing here. This would be negative 3 minus 4 minus 25, and that would be negative 32 like it's supposed to be. So I usually go back and just do a quick check at the end to make sure that it really works in all three equations, okay? All right, so that's the general idea. Now just kind of recap. Really, when you're thinking, you really want to think about these. You don't want to just be memorizing. When you make sense of them, it's so much easier. And the key is creating, this is the important part, creating two equations with the same two variables. So you can't eliminate x one time and eliminate y the next. You need to be getting two equations that you can use that have the same two variables, okay? All right, so let me go ahead and do another one on this video. Okay, I got another example here. This one's a little harder because you see how none of the equations have a 1 out in front of the variable? That just means that you're going to have a little more work to do. So I think it really helps to label the original equations. All right. I could eliminate any of them. Just for fun, I'll eliminate something other than x. Maybe I'll work on z. Okay. So I'm going to work on eliminating z. So if I look at maybe picking equation 1 and equation 2, see how equation 1 has a -4, equation 2 has a +2? I could turn equation 2, I could make a 4 happen right there if I multiplied through by 2. So that's what I'm going to do. So I'm not going to change the first equation. I'm just going to bring that over as is. But with equation 2, I'm going to multiply through by 2 everywhere. Okay. Now, when I add those two equations together, I get 11x plus 4y, my z's are gone, equals -3. This is one of the equations I'm trying to get. That's an equation 4. Okay. All right, now what I have to do is I have to go back to my original equations and I have to pick a different 2 and see how I eliminated z the first time. I have to eliminate z the second time. All right, so maybe I'm going to work on equations 2 and 3 this time. See, I need to do both of them. So I'm looking at trying to create the same number, just opposites in front of the z. So if I multiply by 3 on equation 2 and 2 on equation 3, I'd get a +6 and a +6. I need one of them negative. Okay, so if I did a negative on the 2, that would make it happen. All right, so let's see what I get there. So then when I work through equation 2 this time, my new equation 2 would be 9x plus 9y plus 6z equals -9. And then my new equation 3 is a +4x, because -2 times -2 is +4x minus 10y minus 6z. That's what I wanted to have happen, right? Equals a -6. All right, now I'm going to add these together, and I made it so the z's would cancel out, and I get a 13x minus a y equals a -15. And after I write what I write, I always double check myself, because making a sign error, you just don't want to do that. It really just is very time consuming if you make mistakes. So just be super careful. All right, so now what we're going to do is we're going to pull equation 4 over. It has an x and a y in it. And then we created equation 5, which also has an x and a y in it. And we're going to work on taking that system that we just created and trying to eliminate one of the variables. Now, when you look at that one, you would definitely want to eliminate the y's. Okay, so I'm going to do that. I'm going to come in here, and I want this to be -4. So if I put a 4 out in front and multiply through by +4, that negative times that positive would give me a -4 right there. Okay, So the first equation is going to stay 11x plus 4y equals negative 3. I don't need to do anything to it. But then the second equation becomes 52x minus 4y equals negative 60. So the y's are gone. I get positive 63x equals negative 63. All right. Now in life, things typically don't turn out so nice, but in math books, they almost always do. Okay. You can get fractions, but you normally won't. All right. So I wind up then with x equaling a negative 1. All right. Now from here, you ought to have a good sense of what to do from here. The only logical thing would be to go find an equation that only has one other variable besides an x. So that means go take either equation 4 or equation 5. Okay. All right, so I might go to equation 4. Here was equation 4. Could have used 5 just as easily. And I'm going to wind up putting that negative 1 right here. Okay. So I'm going to have 11 times the negative 1 plus 4y equals negative 3. Okay, so that's 11 plus 4y equals negative 3. When I add 11, I wind up with 4y equaling 8, and then dividing by 4 on both sides gives me that y equals 2. So I knew my x, I now found my y, and to get z, I have to go to one of the first 3 equations that had a z in them. So I'm just going to take one of them. Like, I just took the third one. You could take any one of them. So here was an equation that had a z in it, and now I'm just going to go in, and where the x is, I'm going to put negative 1. Where the y is, I'm going to put 2. And then I don't know my z. Okay. And so I have just z is the only variable. So now I'm just going to work it out. So that's positive 2 plus positive 10, which is 12 plus 3z. I'm going to take away 12. I get 3z equals negative 9. And then when I divide by 3, I wind up with z equaling negative 3. Okay, so I have an x, a y, and a z. And if it were a quiz or a test, what you should do is go back up. And since I used equation 3 right here, when I found, I moved it before it was ready. Okay. All right, I had equation 3 right there. What I would do is go back and check to see if these first 2 equations, if when I plug into those 2, if I get that it works out, then I know I'm right. So on a quiz or a test, it's worth doing that. Okay. All right. All right. So probably don't need to do another one in the video. I'll do it when I post the notes, but I don't think I'll take time doing that in the video. All right. All right. What I wanted to do is give you a sense of, well, what happens if one of the equations was not linear. So let's go ahead and look at that. That's another extension. I'll do a whole separate video on this at some point. But I just wanted you to kind of see, once you know how to solve a 2x2 linear system, 2 extensions we make is we look at having 3 variables and 3 unknowns. The other extension is maybe one of the equations isn't linear. Maybe something like this. Okay, so let me go ahead and look at just kind of what happens when you have something like that. it'll put together what we did, our first idea in the class, together with systems. So I'd like to go ahead and get you to see that. So you don't know yet that the second equation looks like that, but it does. And the first equation would look, let me think about it, would look something like this. And so basically we're being asked to find 2 points of intersection. So that's what's going to be different about this. We're going to have more than one point of intersection, but the concept starts out being pretty much the same. When they say to solve, you're looking for ordered pairs that satisfy both equations, okay? And so you're looking for where the two are equal. So the y from one should equal the y from the other. So just like on the others, I'm going to be able to plug the y in. The x squared minus 6 should be able to go in where the y is. So what I do is I write down 4x minus, and then right there where y used to be, I'm going to be plugging in x squared minus 6. Okay. All right, now, so what's different is I now have a quadratic equation. All right, so let me get rid of the parentheses, then we'll talk about what we're going to do about that. So there's an understood -1 here that needs to get distributed to remove those parentheses. The 4x does not get distributed. It's -x squared plus 6, okay? And then the fact that it's a squared means I'm going to want to get things kind of organized so that they look like they did on the first homework she did. It's a quadratic equation. So I'm going to rearrange things. So I want my squared term first. Then I want my term with an x in it. Those were just being rearranged on the same side. So the signs didn't change. Whatever's in front of it stayed there, okay? And then while I'm at it, let me go ahead and move the 1 over, because you know you need it equal to 0, don't you, when you're solving quadratics. So get everything equal to 0, okay? All right, now on one like this, I'm hoping it's going to factor, but to me having a negative out in front makes it kind of hard to factor. So it is an equation. So I'm just going to divide through by a -1. When I do, make sure I divide everywhere. Divide through by a -1. So I do that because that first term being positive makes it a whole lot easier to work out. Okay. All right, then at that point I'm thinking, okay, I'm either going to use factoring or the quadratic formula. So we're going to give factoring a quick try. Only have one option I can use, which is 1 and 5. Doesn't matter the order you put them in, but it does matter what sign you put in front of them. So here's where I like to write it. Then I realize this would need to be negative, that would need to be positive. And I just check it, right? I just think about it, because the middle term would then give me a -4x, and the positive times the negative gives me the -5. All right, so once you know you got it factored correctly, just continue the solution process. Set each factor equal to 0. Solve each of those and see how that becomes a -1. And this one, when I add 5, I get a +5. Okay. All right, the thing is, this isn't an ordered pair. This isn't an x that goes with a y. These are both x's. But my original problem, this was a system of equations. I'm supposed to be looking for ordered pairs. So you need the y that goes with each of these x's. I need the y that goes with this x, and then I need the y that goes with that one. So this is something that people forget. They don't organize it right. So you should be thinking at this point, you need y for each of these. Let me write that more clearly. Okay, move this up a little bit. I need the y. For each, okay? So what you're going to do is take either equation, but I think equation 2 might be the one that works the best since y is already by itself. And then right there where x is, put a -1 on this one. Square that and subtract 6. And don't forget, a -1 in parentheses squared is 1. So that'd be 1 minus 6. Move it so it's up a little bit. Okay. So that gives me -5 on that one. Then you got to find the y that corresponds to an x of 5. So you do the same thing over here. And right there, you're going to put in the 5 and then work that out. And you get 25 minus 6. That turns out to be 19. So don't forget that was the y on those. Bring that y. Okay. So when x was -1, y was -5. And on this one, when x was 5, y was +19. So you get two solutions to this. And like we noticed before, like I showed you, what's really going on is you have a parabola and a line, and you're getting two solutions. You're getting one of them over here, and then you're getting another one way up here, okay? And you don't know about the graph yet, but that's kind of what's going on underneath it. All right, so what we're going to be working on in the next chunk of material will be still systems, but we're going to work more on what happens when you have systems where maybe you have a parabola or a circle together with a line, okay? So let me stop this video. It got a little bit long. Let me post it.